Hello everyone, welcome to another interesting video. My name is Anthony Adidayo and today we'll be talking about another interesting topic, how to become a pro software engineer or software developer. This topic is very important because a lot of you might be curious, what makes you a pro? Is it about the number of years I've been writing programming or I've been building softwares? You've learned about different programming languages, you've learned different syntax, you've built some mini projects. What's next? What makes you a pro? I'll be talking about 5 major things that makes you a pro. Number one is data structure and algorithms. Why do I need to learn data structure and algorithm? What is even data structure and algorithms? Understanding data structure and algorithms will help you write efficient code. You need to understand what data type to use at some point, what algorithms will help you solve some particular problem. You might think, oh, I can just use an array for this, I can just use a list for this, I can just use a dictionary for this. You need to be able to make right decisions and use the best optimal data structure. And it's very important that you explore this, dive deep into data structures and algorithms, learn about different algorithms that we have there and what kind of problem they can solve. And the data types and data structures that we have out there, learn about their time complexity, learn about their space complexity. This will help you while you're building or writing an algorithms. You need to know, is this data structure the best one or is this data type the best one to use? Understanding which of this data structure to use is one of the major steps to becoming a pro. And why this is very important is because while you're building small projects, you have very few data you're handling. So it's very easy for you to assume that wherever data structure you've used or wherever data type you've used is perfect for that particular scenario. So you have to have a deep understanding about these data types and algorithms and data structures so that you know when to use which one and why you're using it. So imagine data structures and algorithms as a secret tools to solving complex problems. After you've learned about data structures and algorithms and you have deeper understanding about them and the time complexity and their space complexity and all of that, another important step is building large and more complex projects. After you've learned about programming and their syntax by building mini projects, you need to be able to build bigger projects, right? This will push your problem solving skills to its limits and you must be able to do that. So it's very important that you explore more complex projects. Programming is not just about writing code. Programming is about applying your skills to real life problems. So you need to pick more real life or more advanced real life problems and try to solve them. I will advise that you use the knowledge from the existing mini projects you've worked on and see how you can build a more robust project. And while building these complex projects, make sure that you use the knowledge you've learned from data structure and algorithm, implement them while building your project. And of course, one of the best ways to select a complex project is checking online. Check some of the most popular projects you know about and see how you can recreate them. You can select a fintech application, for example, and build most of the features that you feel are complex about that project. You can do a lot of research that can help you understand how some of the complex part about that project is being built. That way you have more understanding and that will add good projects to your portfolio. The experience you gain while building more complex and large projects is invaluable. It will be very useful when you start working professionally. A lot of people spend so much time watching video tutorials and at the end of the day they don't learn anything. That's why I suggest that you think about an application you can build on your own and try to implement some of those features. What makes you a pro software engineer or programmer is not the number of years you've spent watching video tutorials online or the number of mini projects you've built. Is your problem solving skills. Those mini projects will actually help you and those videos will actually help you. But if you want to become a pro, you need to move beyond that. You need to build that project and explore other things that you need to know. And by doing that, you will improve your problem solving skills, which will make you become way better than a lot of people. Another important step is familiarizing yourself with version control systems like Git. I've met a lot of young developers. They have their code on their system, they watch a lot of videos, and they know a lot of syntax. But when you talk about GitHub or Git or any version control system, they have no idea why it is important. I think that's a major problem. They don't understand why it is important. It's very important for collaboration. Version control systems are the backbone of collaboration in software development. Many times you not find yourself working alone. As a software engineer, you find yourself working with other developers. If you don't have a good knowledge of version control systems like Git, you will find it difficult to work with people. So you need to learn about this. Learn about this. And this will actually help you. You don't have to keep most of your code on your system. You can easily push them. You can send it to other people to help you to review. Most times when people come and meet me and say, I want you to review my code, what I do is tell them, push your code to an online repository, then I'll take a look. Then I can add some comments and it's easier for them to get feedback directly on their code. And aside from collaboration, version control system can help you have multiple versions of your code. So you can have like multiple branch with different features or different version of your code. It's very easy for you to revert some of the changes you made in the past or go back to an earlier state in your project. So having deep understanding of version control system like Git is very important to your growth. Another important step is understanding frameworks. Understanding frameworks. This is very, very important. I remember back then when I started learning programming, I know a lot of procedural programming. PHP is one of the programming I started with. Then later on, I learned about OOP. And I believe I have a lot of classes that can help me solve so many problems in different projects, ideally web projects. To me, I just feel, why do I need to learn frameworks? What's important? Why do I need to learn about any framework when I have the class already? What I do most times is whenever I have a new project, I have a engine class that already add some reusable function. I just import that particular function in, and that's all. So simple. I just feel any project I need to work on, I can keep reusing that particular and keep upgrading the version of that particular class. Not really a bad idea, but the only problem with that is that is my own style, or that's the way I structured my own code. I have some other classes too that perform different kind of operations. That is the way I structure my own project. So imagine when I need to work with a lot of developers, that means that they need to understand my own style, my own structure. And in many cases, I might not be able to enforce my own style or my own structure on them, depending on my role in the organization. Why do I think learning framework is important? Learning framework is important because it's easier for you to collaborate with other people. So imagine they don't need to learn my own structure, they don't need to learn my own style. There's like popular ones out there that it's kind of universal. They have a universal way of structuring their projects, and they have their own approach. And in most cases, some of these frameworks have a lot of inbuilt functionalities like security, or they have some of these things inbuilt already. So you don't need to like really stress yourself too much about security or too much about so many other things that you need to like probably write from scratch if you're using OOP or using the procedural approach. So most of the frameworks come with a lot of libraries, methods, inbuilt packages that help you solve a lot of problems that you have to like start writing big code or start thinking a lot about how to approach them. They've already solved some of those problems. So I had to learn about frameworks, and that's one of the best decisions I've made in the past. So keep exploring, be it front end or back end, be it desktop. There is always a framework for most of those programming languages or most of those platforms. Lastly is having deep understanding of database management. This is very important because you'll be working with companies that have large data sets. If you don't have a deep understanding about how some of these database works, then you have serious problem while working with them. You can't just limit yourself to learning about inserting, deleting, retrieving, or those simple things that are basics. You need to dive deeper into understanding this even more. Learn about advanced queries, learn about how to optimize your query, learn about why you need to optimize your query. Why is it important? while you're working with mini projects, it's very easy for you to just write some kind of queries, fetch all these, and do some all kind of spaghetti codes. Diving deeper into database management systems is extremely important, and learning more about advanced queries is very important, because it's not just enough to learn how to insert, maybe delete, or do some basic stuff when it comes to database. You need to learn about so many other things: indexing, how they work, catching, and some of those other things. Learn about how to manage data properly. Those skills will be very useful while you're working, or even while during your interview in big companies or in any company. Those are the skills that you can present that make them feel you are valuable for their company. So I'm going to be dropping a bonus point, which is learning about solid principles and design patterns. I remember when I just started, I didn't know about design patterns, solid principles, and some of these things I've mentioned too. I remember when I just started, I was attempting some interviews to just test my skill and to see if I'll be lucky enough to get a job. And one of the things that came up during interviews is solid principles. So I didn't know what solid principles and design pattern was then, and it really affected me getting that particular role. And later, when I realized what solid principles and design pattern are, it has helped me while writing code. So what are solid principles? Solid principle is just like a guide to help you write a clean and maintainable code. Just take it as that. So let me break them down. So what is solid? Solid is an acronym for 5 major principles. The S stands for single responsibilities principle. The O stands for open close principle. The L stands for Liskov suspicions principle. The I stands for interface segregation principle. The D stands for dependency evasion principle. So depending on which programming language you're using, the solid principle remains the same for all of them. So learn about this principle, and they are actually very helpful while building code. For example, the single responsibility principle just states that a class should only have one reason to exist. A class, you should now have a class, and that same class is the one doing so many different kind of operation. Let's say, for example, in a banking app, you have a class. That same class is the one doing transfers. That same class is also the one doing withdrawal, for example. So a class should just have one reason to exist. So explore these solid principles, see the implementation in the programming language you're using, and have deep understanding about them. So I mentioned design patterns. What are design patterns? Design patterns are a reusable solution to some of the common software design problems that we have out there. And they are divided into 3 major categories: structural, behavioral, and creational patterns. So explore some of these patterns. I will drop links to materials that you can use to learn about design patterns in this video. Please make sure you go through them, have deeper understanding about them. So these are my thoughts, and these are the things that I feel that are important for you to understand to become a pro, which is very important. And I hope that you learn about them and you've learned one or two things about this video. There are so many things I feel you should learn, but I want to make this video as short as possible and make sure that you get these major ones. And hopefully in the future, I'll be dropping most likely a part 2 to this video to talk about some other things that are very important to learn to become a pro software engineer or programmer. Thank you very much for staying to the end of this video. If you are still here, that means you enjoy this video, and give this video a thumbs up. And if you're not subscribed to this channel, please subscribe and click on the like button. Add comments. If you have questions, drop comments in the comment section. I'll be in the comment section to answer most of your questions. Thank you very much, and I'll see you on the next one.